All right, we are going to consider basic electricity as our topic for today. Um, what is electricity? So we know that electricity is one of the most essential forms of energy in the modern world. So from lighting our homes and powering appliances to running industries and enabling communication. So electricity plays a vital role in our everyday lives. So before we dive into the technical aspects, I think it is important for us to understand that there are two main types of electricity. So there are two main types of electricity. Um, we have electricity. Okay. Electricity. So there are two types. We have static. Then we have current electricity. So what is static electricity? This one is just the study of charges at rest. So charge built up on the surface of materials, but they are not moving. So this one, static, is charge at rest. Also charges at rest. At rest. Then what of current electricity? Charges in motion. Charges in motion. Okay. And I want to believe that you have been taught um, methods of production of charges. That is by friction. That is when you rub two materials together, charges are produced. So electron. When we're talking about charges, we're talking about electron. So electron transfer from one body to the other. In atomic structure, we have equal number of electron and proton. Okay. So, when an atom loses an electron, then the body we have more proton than electron. So, and you know that electron is negatively charged, while the charge that proton carries is positive. So when we have more positive than negative, that means we have more proton than electron. For instance, let me give you the instance of, for instance, let's use sodium atom. Sodium is atomic number 11, mass number 23. So it means we have, for proton, we have 11 protons in sodium atom. Then electron, we have 11. Okay. So if there is a transfer of electron, or if this sodium atom loses one electron, then it means the body is going to be positively charged because it has more positive charge than the negative. It's going to be positive. The dominant charge here will be positive. So that is how charges are being produced, at least by friction, when you rub two bodies together. Like when you rub ebonite rod. Ebonite, I want to believe that you have been taught ebonite rod plus 4. Okay, when you rub the two together, so electron will transfer from ebonite rod to 4. You understand? Okay, so that is static electricity. Another method of producing charges at rest is by electrostatic induction. By electrostatic induction, that is when you place a neutral body near an already charged body. or when you place an already charged body close or near a neutral body, that so electron or charges are transferred from the charged body to the neutral body. So the both will now become charged. Then another method is by contact. So when you place a charged body in contact with a neutral body, a bit uncharged body, I mean neutral body. So that body, electrons are transferred from the charged body to the neutral body. So I'm just trying um, to tell you and to give you a kind of revision on the static electricity. But our attention today is on current electricity. On current electricity, that is the charges in motion, the one that deals with the flow of charges or the flow of charges. So what is called current? What is current? We are going to define current. At the end of this class, you should be able to define current and how is being measured. How current is being measured. So which instrument is used for that for the measurement of current and the unit of current. So these are the things that you should be able to say at the end of the class. So we are going to do simple calculations on electricity. Okay, now let's continue. Let's continue now. What is electricity? Electricity is the flow of electric charges, like I said. Is the flow of electric charges. Flow of electric charges. Okay. And when we're talking about charges, we're also talking about electrons. So charges or electrons. So through a conductor, such as wire. So we have conductor like wire, like this is wire. When current or when charges flow through wire, then that one is called electricity. It's the flow of electric charges through conductor, such as a wire. That is what is called electricity. Okay. Now, these charges are usually produced by sources like battery. Yes, like battery. So, generator or power stations. So this kind of electricity are the charges are being produced by from those sources. So we have solar um, um, as an electricity from solar generator. So we have the chemical. That one is the battery. Okay. And electricity can be static, not moving, or current flowing. Like I've told you that electricity can be static, not moving, or current flowing. In this class, we focus on current electricity. So we are going to focus on current electricity, the movement, the motion of charges, the flow of charges. That's what we are going to deal with. Okay. Now, let's look at the current electricity. Let's start with current electricity. Now, electric current. What is electric current? Electric current is the time rate of flow of electric charge. Time rate of flow of electric charge. So I said current electricity is the study of charges in motion. Charges of motion when they flow from one part of conductor to the other. Okay, that is known as electric current. And the symbol that we use for current is I. When you say I, it means current. It means current. Okay. Now, the rate of flow. Take note of this word. The time rate of flow. If the rate of flow is fast, then the current will be high. You say the current is high. It means the rate of flow. Okay, the rate of flow is high. That is the amount of or the quantity of electricity, the quantity of charges that flow through conductor per time is fast. Okay, so that is when we have high current. But if the quantity is low, if the quantity is low, the quantity that flow is low, is slow, then we are going to have low current. So the fast flow will produce high current. But the slow, when the rate is slow, then the current will be low. All right, so that is why we define electric current as a time rate of flow of electric charge. So the formula is I equals to Q over T, where I equals current in amperes. I equals current in amperes. So the unit of current is ampere. Ampere. So or you write AMPERE, or you write capital letter A. That is ampere. When you say 3 ampere, like 3 ampere, okay, that is 3 ampere. So we're talking about current, 3 ampere. So the unit is ampere. Okay. Then Q is the quantity of charges in coulomb. The quantity of charges in coulomb is Q. Okay, the quantity that flow. Then T is the time. So that is why current is Q over T. Current is Q over T. That's I equals to Q over T. That is quantity of charges, quantity of electric charges over time. That is what gives us current. Okay, and the instrument that we use to measure current is called ammeter. It's called ammeter. You can see it here. You can see ammeter here. This meter. This is calibrated from 0, 5 in 5, 5. As you see, 0, 5, 10, 15, 20. So you see the calibration. Okay, and the symbol is this. Look at the symbol. Look at this circuit. The symbol is like the circle and capital letter A at the middle. You have the circle and the capital letter A in the middle. Okay, so this is the symbol of ammeter. Ammeter in the circuit. Okay, this line you are seeing are wires. Okay, let me show you ammeter half here. Okay, see, this is the ammeter. Okay, you see the A written, the A is written here to show the ammeter is ammeter. So we have another one. This one is voltmeter. When we get there, I will explain this one. So this one is used to measure current. So just connect one terminal of the conductor to this place, another one here. So then you will see the die moving like this. Then you can read the quantity of electricity that is flowing through that conductor, like wire, at that time. Okay, so the formula, if you're asked to calculate the quantity of electricity that flows per time, so you make use of this formula, I equals to Q over T, and that's the formula we are going to make use of now. I'm going to make use of that formula now. Don't forget, Q is the quantity of charges that flow. Quantity of charges that flow. Look at this wire. So the quantity of charges or electrons is also called charges. Okay, also known as charges. So they flow. So when there is a flow through the conductor, then we call it current. It becomes current. You understand? So the flow is current. Okay. Now the rate of the flow The rate of the flow can be fast and can be slow. If the rate is fast per time, then the current will be high. But if the rate is slow, the rate of flow is slow, then the current will be low. Okay. For instance, if in 1 minute 10 coulombs of electricity, of electric charge, 10 coulomb of electric charge flows per minute. Let me say per minute. Or let me say per minute. Then at another instance, 20 coulombs of electric charge flows per second. We know the first instance, the current through this conductor will be lower compared with the when 20 coulombs of electric charge flows per second. So the more the flow, the more the quantity of electric charge that flow per seconds, so the more the current, the higher the magnitude of the current that they are going to have. So it's going to be either high or low. So what determines low current is the rate of flow. Whether current is low or is high, what determines is the rate of flow. Okay, so and that is why we want to make use of this formula now. Now let's look at look at these circuits. We are still coming back to circuits when by the time we are dealing with circuits, electric circuits. So I'm going to explain this for you. I only brought this circuit to show you the symbol of ammeter in electric circuit. So when you see this symbol, this circle, and letter A, capital letter A inside circle, it means ammeter. So that is the symbol of ammeter. So I'm going to tell you other symbols, other electrical symbols of other electrical components as we continue. So you can see this is the ammeter and this is the symbol. Whenever you see this symbol, it means in this circuit here, this kind of circuit, now we have ammeter connected here. We have ammeter connected there at that part. All these lines we are seeing here are wires. They are wires. And this one we are seeing here is key. Anyway, I'm going to explain that one later, but let's just concentrate on electric current. Now, electric current is measured with ammeter. So the instrument used is ammeter. The unit is ampere. Don't forget the unit of current is ampere. Ampere. So when you have 3 ampere, it means current. Okay. Then when you have coulomb, look at coulomb. When you have 10 coulombs, 10 coulombs. When you have 10 coulombs, it means this is the quantity of electric charge. Quantity of electric charge. So this will be Q, going to be Q, 10 coulombs. That is the quantity of electric charge that flows. Then the time here, let's say the time could be 5 seconds. 5 seconds. Okay. 10 coulombs of electric charges flow for 5 seconds. Okay. What will be the magnitude of the current in the circuit or in the conductor or in the wire? So the current will now be I equals to, is Q over T. Q is 10, going to be 10, then time is 5. So 10 divided by 5 will be 2. That is 2 ampere. So the magnitude of the current that passes through that conductor at that point, at that moment, is 5 ampere, 2 ampere rather, 2 amperes. Okay. Now, let's look at some questions here. Let's look at some questions. Before we continue, let me show you again the ammeter. This is ammeter. We use it in the lab, in the laboratory, to carry out experiments in the lab to measure current flows through a particular circuit. Okay. All right. Now let's deal with this question. A charge of 30 coulombs flows through a wire in 5 seconds. What is the current? A charge of 30 coulombs, sorry, 30 coulombs, a charge of 30 coulombs is 30 coulombs flows through a wire in 5 seconds. What is the current? Okay, so here now you write out the parameters. Solution. Let's write the solution. Okay, let's write the given parameter. In this question, we have 30 coulombs of electric charge. So electric charge Q is 30 coulomb. You can use capital letter C if you don't want to write coulombs in full. 30, then capital letter C, that's 30 coulombs. That's the quantity of electric charge that flows through the wire in 5 seconds. Okay, already the time is given, T, time is 5 seconds. 5 seconds, that is 5 seconds. So what will now be the current? What will be the current? Okay, then what you do is to write the formula out. So write the formula. I equals to Q over T. Now let's substitute. Q is 30, then T is 5. So 30 divided by 5, that's 6. So the unit is A, that is 6 amperes. 6 amperes. So that's the current in that wire, the current that flows through that wire. All right. Okay. So our answer is 6 amperes. So the current through the wire is 6 amperes. 6 amperes. That's current through the wire. Okay. Let's go for the second question. An electric circuit has a current of 4 amperes. How much charge flows through the circuit in 10 seconds? An electric circuit has a current of 4 amperes. How much charge flows through the circuit in 10 seconds? Okay, now let's solve it. Solution. Okay, solution. Okay, now the parameters in the question, we are given the current. The electric current is given. The value of current is given. I equals to 4 amperes. 4 amperes given. Okay, how much charge? So we are looking for Q. How much charge is given? Let's put question mark there. Okay, how much charge flows through the circuit? So the circuit in 10 seconds, that 10 seconds is time. 10 seconds. 10 seconds. So this, you write out the parameters in the question out like this. So when you write it out like this, now to now help you to pick the formula you want to use. Okay. Now let's see this. Okay, let's write the formula. I equals to Q over T. I equals to Q over T. And that will give us I. What is I? 4. Then Q, we don't know Q. That's what we are calculating. And T is 10. Okay, when you have it like this, you know, you cross multiply. cross multiply. So Q now equals to, when you cross multiply, Q will be 4 times 10. Q is 4 times 10. So Q will now be 40. So the unit of coulomb of electric charge is coulomb. 40 coulomb. 40 coulombs. 40 coulombs. So it means in that circuit, for you to have a current of 4 ampere in 10 seconds, 40 coulombs of electric charge must flow through the circuit in 10 seconds. Okay. Okay, let's have more. Let's have more question. Let's treat more question. Okay, question 3. If a current of 2.5 ampere flows through a circuit for 8 seconds, calculate the total charge that has passed. Okay, now solution. Okay, the current given, we are given 2.5, that is I. I equals 2.5 ampere. 2.5 amperes. Then for 8 seconds time is given 8 seconds. 8 seconds. Then calculate the total charge. Now to calculate Q. To calculate Q is the total charge. Okay, now let's just let's get the solution. So the formula, write the formula. I equals Q over T. Okay. All right. So Q over T, and then you now use 2.5. I is 2.5. Now 2.5 equals to Q is not given. Q over T is given 8. It's given 8. So when you cross multiplied, Q equals to 2.5 times 8. 2.5 times 8. What would that one give you? So it's going to give you 20. That is 20 coulombs. 20 coulombs of electricity flows through the circuit to produce the current of 2.5 amperes. Next question. How long will it take a current? This is question 4. How long will it take a current of 3 ampere to transfer a charge of 24 coulombs? How long? You know what is meant by that? How long? How long is talking about time? How long is talking about time? It means we have to calculate time. How long will it take a current of 3 ampere? Current I equals 3 ampere, 3 amperes, to transfer a charge, given a charge Q of 24 coulombs, 24 coulombs. Okay, now what you do next is to write the formula. The formula is I equals to Q over T, and the current, let's substitute. After you have written the formula, the next thing is to substitute, do substitution. I is 3 equals to Q is 24, then T unknown. That's what we are looking for now. We are calculating. So when you cross multiply 3 times T, you say 3 times T equals to 24. 24 times 1 is 24. Okay, so when you divide both sides by 3, okay, you cut it now. So T equals to, 3 here 1, 3 in 24 is 8. So T will be 8. Then the unit of time is seconds. Second. So don't worry, you need to put the unit of time there, which is 8 seconds. Okay, so just make use of the formula I equals to Q over T, then you substitute and you now cross multiply as the case may be. Now the next question. A device allows 15 coulombs of charge to flow in 0.5 minutes. Find the current in amperes. Now you are given a hint there, convert minute to seconds. When you are given time in minutes, it must be converted to seconds. So solution now, let's start the solution. So what are you given? We are given the quantity of charge. Electric charges Q is given, that is 15 coulombs. 15 coulombs. Then time is given, T is 0.5 minutes. Is 0.5 minutes. What is 0.5 minutes? Half minute. 0.5 minutes means 30 seconds. 30 seconds. Okay, 30 seconds. That is 0.5 minutes. That is half of a minute. It's 30 seconds. The time must be converted to seconds. Okay, it must convert to seconds. So find the current in ampere. I in ampere. You have to look for ampere. Okay, let's find current. Okay, I equals to Q over T. So therefore, what is I? We are looking for I. I equals to Q. Q equals to 15. Then time is 30 seconds. So when you cut it, so 15 here, 1, 15, 30, 2. So I'm going to get 1 over 2. Or current will now be 0.5, the unit, then ampere. 0.5 ampere. That will be the current in that device. Okay, through that device. That will be the current. Okay, number 5. I think that is the last question. So that will be the last question. I will now give you the class activity. Look at it. Class exercise. I want to give you this class exercise, and you must make sure that you solve the questions and get it across to me to check. When you get the solution, get it across to me. I'll mark it. You see question number 1. A total charge of 60 coulombs flows through a wire in 15 seconds. What is the current? Question number 2. If a current of 0.5 ampere flows through a lamp for 10 seconds, how much charge passes through it? Question number 3. How long will it take a current of 1.2 ampere to transfer 18 coulombs of charge? Number 4. A wire carries a current of 3 amperes. Calculate the amount of charge that flows through the wire in 1 minute. Don't forget the time must be in seconds. Must be in seconds. 1 minute means is equal to 60 seconds. Okay, then the last question, number 5 here is an electric heater operates with a current of 6 ampere for 40 seconds. What is the total charge used? So these questions are very simple and I need you now. The number 6. If a charge of 0.75 coulomb passes through a circuit every 0.5 seconds, find the current. So, and up to question number 10. So you have 10 questions here to answer, and you have just 30 minutes to do that, and you get it across to me. So that is what we have done. Let me just quickly do the recap of the lesson. We started with 2 types of electricity. We have static electricity and we have current electricity. Static electricity is when charge built up on the material, that it charges at rest. Charge are created, they are produced, but they are not moving. Okay, they are not moving. And we have current electricity. So the current electricity deals with charges in motion. So when the charges are now moving, then it becomes current. If charges are produced and they are not moving, then it's not yet current. So charge must move. So charges in motion is called current electricity, and that is what we dealt with. And I studied that current, what electricity is the flow of electric charge, of course. It's flow of electric charges through conductors such as wire. Okay. Then we talk about the electric current. That electric current is the time rate of flow of electric charge. Time rate of flow of electric charge. If the flow is fast, that is the charges, if the rate at which they flow through a wire, if the rate is high, then current is high. If they are fast, then the current will be high. But if the rate is slow, this is slow, it's not fast, then the current will be low. You understand? So then I also said when you see letter I, it stands for current. Letter I stands for current. Letter Q stands for the quantity of electric charge. Quantity of electric charge, and the unit of that is coulombs. Coulombs. So, or capital letter C. Capital letter C. Then T is the time. Of course, when we say time rate, talking about the rate, it's a function of time. So time must be in seconds. If we are given an hour, it must be converted to seconds. Then, and the instrument that we use to measure current for in any circuit is ampere. And I already told you that this thing you are seeing here, this symbol you are seeing here, is the symbol of ammeter. You can see the ammeter here. Here you see the meter, and you see capital letter A here, it means ammeter. So we use this in the laboratory to measure the quantity of electricity in a circuit. Okay, in a circuit. And also you see the symbol here. You see the symbol A. When you see circle and capital letter A, it stands for it's a symbol for ammeter. A symbol for an ammeter. So we are going to stop there today. So next class we look at potential difference. You see, current cannot just flow. Something must push it. Electron cannot flow. Something must push it. Yes, that thing that pushes it, that pressure that will cause a charge to move from one point to another, that's what we are going to study next class, and that is called potential difference or voltage. It's a pressure. It's something that will push. That is why you see the potential difference and current, they are proportional to each other. So when one is high, the other two will be high. Okay, they are directly proportional. When the pressure is high on the electron, on the charges, then the rate of flow will be high, and that will cause the current to be high. So if voltage is high, current will be high. You understand? So voltage is like a push. It's a pressure that we exert on the electron, and the electron start moving. And it is that pressure that determines how fast the electron, the charges, how fast they are going to move. It determines the rate of flow. Okay. If the rate of flow is slow, it means the pressure is not much. The pressure is not much. But if the rate is high, it means there is more pressure to cause the charges to flow from one part to the other in the circuit. So we are going to look at that in our next class. So I will be expecting your question any moment. So please send it across, and I want to use that to evaluate you. Used to evaluate the class. So, all right. Until then.